Hi buddies. Today we will start another normal form, that is Greivak normal form, and Chomsky normal form has been completed successfully. So now the problem is a context-free grammar is given to you, and now you have to convert it into the Greivak normal form. So it is just similar to the Chomsky normal form, but the rules are different than Chomsky normal form. So a context-free grammar is in Greivak normal form if the right-hand side of each rule has one terminal followed by zero or more non-terminal or the variable. Means if all the productions are in the form of a to a alpha, where this a belongs to terminal and this alpha belongs to variable asterisk. That means any combination of variable, any iteration of variable is permitted in case of Greivak normal form. But the condition is always your production must be started from the terminal. So it is the restriction over it. So just we have to convert all the productions of a context-free grammar in that particular form. That is a to a alpha. So now start with some examples. So there are certain examples you can see. In this case, all these productions are in GNF, that is Greivak normal form, because in this case, this is suppose S to AB. So in this case, this A is the terminal and then it is a variable. So it is valid production as per the given, as per the defined production rule. And similarly, S to BA is also in GNF because it is a terminal, then it is a variable. So it is permittable in case of Greivak normal form. Another one is this is only a terminal. So now the point of communication is this type of production valid or permittable in case of GNF? Yes, of course, because you can see here the production rule, defined production rule is a to a alpha. So we here alpha is what? Alpha is just v star, means any combination of variable including null. So if it is null, then you can find only the terminal. So it is valid production rule for the Greivak normal form. So a to a is also valid production. Another one is suppose a to as. Similarly, it is a terminal and it is a variable, so it is valid production rule. And now another one is a to BAA. In this situation, you can see this there is single terminal and two variables. So now the point is this particular production is valid for GNF or not? So just see the generalized form of the production rule of GNF. In this case, a to a alpha, alpha is v asterisk, means any combination. That means any variable of length 1, length 2, length 3 is permittable in case of Greivak normal form. So this is again the valid production in GNF. Similarly, you can find the production of B, that is B to B, B to BS, B to ABB. So all these productions are in GNF, that is Greivak normal form. So a grammar, a context-free grammar is given to you. Then in this case, we have to convert all the productions of that grammar in that particular format, that is A to A alpha. So now, before going to start the Greivak normal form, just we will start some lemmas that are used to convert a grammar into the GNF. So start with lemma 1, you can see here. So lemma 1 is what? Just see, let G is equals to Vn sigma Ps is a context-free grammar. Then it is important that if any production in the form of A to B gamma, means there is any production of A, that is A to B gamma, where B productions may be B to beta 1, beta 2, beta 3 up to beta S, then the new production rules, that is that after eliminating this A to B gamma, you will find the new production rule as P1 is equals to P minus A to B gamma, that is the previous one, and union A to beta I gamma. This is an important point here, that A to beta I gamma, where I varies from 1 to S. So it means that simply Suppose A to B gamma is any production in P, then after applying lemma 1, we can substitute the values of B or the production of B here. Then we will find the another production rule, another production rules, right? This is simply lemma 1. In case of lemma 2, just see here. So simply lemma 1 related to the substitution of value, substitution of productions. So now lemma 2 is an important part because it is about the left recursive, right? So how can we eliminate the left recursive problem if it is in the any context free grammar? So it is an important part. So just start a lemma 2 that let G is equals to Vn sigma Ps. This is suppose Vn sigma Ps. These are 4 tuples, as you know, to represent any grammar. Then A productions are in the form of A to A alpha 1, A alpha 2, A alpha R, and beta 1, beta 2, beta 3 up to beta S. Clear? So in this situation, the important point is this beta 1 should not be start with A, means किसी variable से ये start नहीं होगा. So in this case, just you can see this is the problem of left recursion, that A to A. But here this is free from left recursion problem. So in this case, how can we overcome this type of problem or the problem of left recursion? Just we can write the productions that are free from left recursion. That is beta 1, beta 2, beta 3 and beta S. So just write all these productions of A variable, right? And after that, introduce a variable, that is Z, and concatenate with all the productions, right, of A. So just we can write here B1, beta 1, beta 2, beta 3, and Z is new variable that is associated here, beta 1 Z, beta 2 Z, and beta S Z. Where what is Z? So Z is what? Z is simply the alpha 1, alpha 2, alpha 3. That is the this is the simple collection of variable and terminal that are after the left recursive variable, right? So just you can write the values of or the production of Z, that is alpha 1, alpha 2, alpha 3, alpha R. So just write down here Z. And similar to the previous A productions, just we have to concatenate that Z variable or the introduced variable along with the alpha 1, alpha 2, alpha R. So finally, you can find the productions in the form of Z2 alpha 1 Z, alpha 2 Z, alpha R Z, and simple Z2 alpha 1, alpha 2, alpha R. So the finally, after applying lemma 2, you will find the A production in this format and Z productions are in this format. So simply meaning is you can after removing the left recursive problem from the grammar G, you can find the equivalent grammar, that is G1, by using this particular lemmas. So these lemmas are helpful to convert any grammar into GNF. Now just we should start with an example so that we can explain each and every point very carefully and clearly. So suppose this is a question that you have to convert a context-free grammar into Greivach normal form. So in this case, you can see easily just S to A to SSB. These are the productions that are given to you. So first step is just we have to check whether there is no null and unit production in the given grammar, or and the grammar should be in Chomsky normal form, right? So simply this grammar is in Chomsky normal form. So next step will be started, and next step will be the renaming the variable. So the point of communication is now why we require to rename the variables. So to synchronize, for the synchronization purpose, we require to rename the variable and rewrite the production. So how can we rewrite or rename the variable? Just see. Here there are two variables, as you see, S and A. So we can rename these variable by A1 and A2. So just S can be renamed as A1 and A can be renamed as A2. You can rename it by B1, B2, whatever, right? So these production rules can be rewritten as A1 to A2, A2 because S is renamed as A1. So you can write here A1 and A is replaced as A2. So you can write here A1 to A2, A2 and slash A. So these production rules are converted in this format and we rewrite all these productions. Now we have to convert all these productions of A1, A2 into A1, A2 productions into GNF. So now start with A1 production, that we assume that A1 productions are in required form. Initially, we will assume that A1 productions are required form and we will try to convert the productions of A2 into the GNF. When A2 is completely converted into GNF, then we will convert A1, right? So initially, we will assume that A1 productions are in required form and we will try to convert A2 production, right? So A1 productions are this one and these productions are in Greevec normal form or the required form. Now A2 in A2 production, you can see A2 to B is in required form because the required form is what? A2 A alpha, right? Where alpha is what? It is variable Vn star. So in this situation, A2 to B is in a required form. You can note down it this one, A2 production, but A2 to A1, this one, it is not in the required form. So in this case, we have to check that whether lemma 1 can be applied or lemma 2 can be applied. So in this situation, you can see this is the form of A2 B gamma, right? Simply it is the form of this one. So how can you say that this is in the form of A2 B gamma? Just see here, it is A2 and here it is A1. So this is simply the form of A2 B gamma. If A2 is there and A2 is there, so then in this case it is in the form of A2 A alpha. So simply with the help of this production rule, we can see that this is the form of lemma 1. So just we have to substitute the value of A1 here. So now the productions can be changed as A2 to A1 की जगह पर value put करेंगे. So how can we put the values of A1? That is A2 or A. So just initially we start with A2. So in place of A1, we can put A2 and this is finally A1. So the production of A2 will be A2 A1. You can see easily A2 A1. And another one will be A1 to A. So in place of this A1, you can put value A. So you will find here A1. So this is another production of A2. And A2 to B is already in the form. So total number of productions of A2 are, you can find here this one. In this case, now this is in GNF and this is in GNF, but again this is not in GNF because in the initially you must have the terminal. So now we will try to check whether any lemma can be applied. So in this situation, you can find here that it is in the form of A2 A alpha, right? So it is what? It is simply lemma 1 because A2 is here, left side, and right side A2 is here. So this is lemma 1, lemma 2. So how can we apply lemma 2? In the simple case of lemma 2, just write this is the simple case of left recursive, right? So write all the production of A2 that are free from left recursive problem. That is A1 and A1 and A2B. These two productions are free from left recursive problem. So just write down these two productions. Now assume a variable that is suppose Z2, right? New variable, and concatenate it with A2 production. So just concatenate A2 Z2 here, A2 to B Z2. So these are the simple production of what? A2. Now the point is, what is Z2? So Z2 will be the alpha. That is, suppose A2A alpha. So this whole thing is alpha. So Z is what? Z is A2A1, A2A1. And now again we will write to Z production of Z2 similar to the A2 production, that is A2A1 Z2. So these are total productions of A2 and Z2. Clear? So now I create a box in which A2 productions are there. So you can find A2 productions and you can check now all the productions of A2 are in the required form or are in the Greevec normal form. Now, the point is, initially we assumed that A1 productions are in required form, but it was not in the required form. So now we will try to convert A1 productions into the Greevec normal form. So A1 productions are A1 to A2, A to A. So you can see here A1 to A is in required form, but A1 to A2, A2, this is not in GNF. So how can we apply lemma here? You can find that A1 to A2, this is the form of A to B gamma. So we can substitute simply the value of A2 here. And we can find the productions as A1, A2, B A2, A1 Z2, A2, B Z2, A2. Simply we are just substituting the values of A2 here. So you can find the answer, that is A2 A2, the A1 A2, A1 A2, B A2. All these are the productions of A1. And now you can see that A1 productions are completely converted into Greevec normal form. So A1 has been completed, A2 has been completed clearly, but you introduced a variable, that is Z2. So now our responsibility is to convert Z2 also in Greevec normal form. So simply Z2 is what? Z2 is a variable that it will be in the form of A2 or A1. So if it is in the form of A2, so just you can substitute the values of A2. If it is A1, then substitute the value of A1. And because we have already calculated the value of A1 and A2. So simply Z2 here, Z2 to A2 A1 and Z2 to A2 A1 Z2. So simply just we are substituting the value of A2, and A2 is already converted into Greevec normal form. So just put the value of A2 here, you will find A1 A1, right? B A1. Next A1 Z2 A1. So in this place just I am putting the values of A2 from the equation 1. You can see easily. So you will find Z1 Z2 in this form. And similarly this is again a Z2 with the same production excluding this Z2, right? So you can copy the same thing and just concatenate Z2 at the last, or again you can put the value of A2. Both are the same thing. Finally you will get the same answer. So these are the productions of A1, A2 and Z2, and now all the productions are converted into GNF. So it is complete conversion of GNF from a context-free grammar. Means a context-free grammar is given to you, and then you can convert it in the form of Greevec normal form or in the form of A to A alpha. So now you can verify it that all the productions are in this form or not, right? You can verify clearly. So this is the simple rule that I already discussed, that A to A alpha, here the terminal, and then any combination of variable. So each transition is started from a terminal. So it is simply all the productions are in GNF. So this is the simple way to convert the GNF. Another example is S to AB, BS, B to SAA. And on the same way, we can convert the given context-free grammar into GNF. So similarly, in this case, start with the steps 1 and 2. There is all the productions are Chomsky normal form, means no null production, no unit production. Then we will start from the rewriting the variable or renaming the variable and rewriting the productions. And finally, we will find 24 productions after applying lemma 1 and lemma 2, and all the productions are in GNF. So you can match your answer. This is for your practice purpose. You can match your answer whether it is correct or not. If you have any problem, that we will discuss in the lecture. Thank you.